right. Welcome everybody to the University of Idaho Integrated Design Lab Fall Lecture Series on Energy Efficiency. Today brought to you from the Center for Advanced Energy Studies. Also want to thank several of the funding sponsors who helped make today possible and the series in general possible, which include the Northwest Energy Efficiency Alliance, their Better Bricks program, Idaho Power Company, Idaho Falls Power here in Idaho Falls, and the Center for Advanced Energy Studies Energy Efficiency Research Institute. I want to just mention the fact that this is our first lecture not delivered out of the lab in Boise, so this is a little bit of an experiment for us. And we had some weather today in Idaho Falls, so sorry for the folks viewing online, but you might see a few people trickling in through the camera. For folks online, if you do want to send questions, feel free to do so. Hopefully this has been updated onto the screen, but if you do have questions, send them to kevinv@uidaho.edu. That's my email address, kevinv@uidaho.edu. And I will check them on my phone and interrupt the speaker tonight. For those in the room, after the event, we will have a little gathering available. The United States Green Building Council Idaho chapter has done us the favor of sponsoring a little social after the event just on the other side of this wall. And Doug Peterson, who is the co-chair for membership for the USGBC, will be here to answer any questions and talk about the USGBC Idaho chapter after the event. With that, I'm going to make a very brief introduction to our esteemed presenter for the evening. I was going to get your name wrong, but I think I'll try. Deanne Desai?
Very good.
Very good, thank you. I have trouble with folks butchering my name. Yours is short, but it's a little tricky. Deanne Desai is here from Georgia Tech. Thank you for coming. She is a project manager there. She's been with Georgia Tech for around 12 years. And she's also been intimately involved with the development of the ISO standard 50001 on energy management, which she'll be talking about tonight. I'm sure she'll give you the history, but her involvement goes back to the beginning of the standard, which was in October of 2008, through to its publication just recently in June of this year. And as I gather, will be involved in education and training, as well as further development with the committee. It's an international committee, so I really appreciate you coming. And background is in mathematics and chemical engineering, is that right? Did we get that close? All right, very good. Well, with that, I'll just restate for folks online, if you want to email questions in, know that there'll be a few minute delay, and my email address is kevinv@uidaho.edu. And Deanne, I'll let you take it from there and decide how you want the folks in the room to ask questions or not.
Okay.
Thanks so much. One last thing. If you haven't been to the K's, bathrooms are all the way down the hall. And for folks who just walked in, please do sign in. If you need AIA continuing education units, make sure you give us your AIA numbers. And one more logistical thing I just remembered. I usually have my cheat sheet, but for folks online, CEUs will be available for you as well. Make sure that you request them as you're watching live, and then we'll get you the test and you can take it for credit. With that, Deanne, thank you so much for coming.
Good afternoon and welcome. I love questions, so anyone who has a question at any point, feel free to ask questions. They are wonderful. And if you have a question, someone else has the same question as well, so feel free. International standards may not be a topic you are familiar with, so I thought I'd start by giving you some background on who writes international standards. There are 3 international standards bodies. Starting from the bottom, moving up, ITU is the oldest of the international standards bodies. They focus primarily in radio and other telecom communication areas. Then we are followed by IEC, this one here. Was founded in 1906, and it focuses on technology-based standards related to electronics and electricity. So very technical standards. Then we have ISO. ISO is all the others. So anything that didn't fit in ITU or IEC is an ISO standard. And there are a number of places where ISO and IEC work together. So it can be a joint ISO and IEC standard. So those are the three basic bodies that write international standards. ISO is a non-governmental organization headquartered in Geneva, has 160 national bodies, which are 160 countries, who are members. And of those 160 countries, 107 have voting rights. That means they can influence what goes into an international standard. Each country gets one vote. So the U.S. delegation, which attends these international meetings to represent your views, gets one vote. So we have to be persuasive in our arguments as we attend these meetings to ensure that our constituents' opinions are represented. So basically, we have a number of standards. Just in the past year, there's been over 18,000 standards written. This work is carried out by experts in the area, and each country develops a mirror committee for each topic they wish to present or participate in. And in the U.S., we have a mirror committee related to energy and energy management. So what's the history of this? Well, believe it or not, the U.S. was the first energy management system standard, the first. That's not typically where the U.S. is in the standards world. We tend to follow in standards, but in this particular arena, energy, we were first. Followed shortly by the Danish, and all of this happened, actually the U.S. first standard was issued in 1999, and the Danish standard was issued in 2000. The American national standard is called Management System for Energy, or ANSI-MSE is the name of it. Followed fairly quickly on the heels of the Danish standard was the Swedish standard. And then after the Swedish standard, the Irish standard. Then there was a standard issued in Thailand. So you can see that there is what we call global proliferation occurring. This is what gets the attention of different people, primarily related to trade and global barriers. Because if there are multiple standards in multiple countries that an organization has to meet, this can cause an issue. So there was a meeting of the UN Industrial Development Organization, UNIDO, and they met in Vienna in early 2007. And they actually sent to ISO a recommendation and a request for an international standard on energy management. So in late 2007, the U.S. wrote the proposal for this standard in response to the UNIDO request. And we were granted that proposal, and the ISO formed the group to write 50001 in 2008, and the first meeting of that committee was in October of 2008, hosted by the United States in Washington, D.C. In the meantime, in between that proposal being submitted to ISO, the European community decided to write their own standard on energy management. And so they wrote a standard or started work on what is known as EN 16001. This caused a little bit of interest in the international community because now there was a European standard being developed as well as an international standard being developed. To continue the proliferation, and as the international work continued, Korea decided to write a standard as well. So there were a lot of different views on what makes up energy efficiency and energy management. And all of these had to be discussed throughout the development of ISO 50001. So down here, what you see is the publication of the standard itself. And so the committee draft was finalized in 2009, and this is also when China decided to join the fray and publish their own standard. The committee draft is a stage where you develop a lot of consensus internationally, and then it moved to a draft international standard and a final standard and was published in June of this year. Now, the committee that was formed to write this standard was authorized to write one document and one document only. And that is what this word PC stands for. It means Project Committee. So it was a very focused effort by this group of international experts. This year, the committee was transformed to what is called a technical committee, or a TC. And our next meeting is in October of this year, again hosted by the United States in Washington, D.C. And now we'll be working on a broad array of topics outside of 50,001 to support 50,001. The other two energy committees that are related to the work that we do and that utilize our work, one is a terminology group. This is a joint group with ISO and IEC, and it will be a joint standard between the two. It's the vocabulary or the dictionary of energy terms. The other committee is one on energy savings calculations. So you managed it well. Did you get any results? Well, that part of it is handled by this group up here. What did the results prove? That's handled by this group down here, energy savings calculations. And these two groups work fairly well together, actually. So how was this actually developed? Well, like I said, it was a request submitted by the United Nations Industrial Development Organization to ISO, responded to by the U.S., who wrote the proposal and who chairs the International Committee, and in response, the now Technical Committee 242 was formed. If you want to know how ISO numbers their committees, they number them sequentially. So we got the number 242 because we were the 242nd committee they formed. Their process for developing documents is a consensus-based process that involves a number of ballots, comments, and resolutions. It goes through, basically, a 6-stage process. It starts with a new work item proposal up here. So somebody saying that this work needs to be done. Then it moves through building consensus, which is a very fun stage where everybody enjoys arguing over what should and should not be in the document. Moves to another stage, again consensus building, to resolve any issues that came up in that stage, and then goes on to a draft stage. In this stage up here, only the people within the committee see the document. So only the people within TC 242 would have seen the document and commented on it. Even so, we had over 300 pages of comments. So you can tell this was a very active group of experts. At this stage, when you get down here to draft standard, it's submitted to all the countries involved. All 160 countries got to be involved in, see the document, and comment on it. Those comments are resolved, and then it moves to a final draft standard. This is an up-down yes-no vote. Yes, we agree with this, or no, we don't. After that vote, the document is published as an international standard. This whole process takes anywhere from 3 to 7 years. 3 years is considered fast-tracked, 5 years is considered normal, 7 years is considered a slow track. ISO 50001 was published in just under 3 years. So it was a very, very fast-paced development. By ISO standards, it was light speed. Most ISO documents are published in 5 to 7 years. The energy group, being energy-minded, not only had face-to-face meetings, but was the first technical committee to meet through electronic means using webinars. To establish and utilize global webinars is a very interesting technique because it's always nighttime somewhere. So it was a very interesting process to work through. How many countries participated? 61. And there are different types of membership. Participating countries, those are the ones who are extremely active, send experts to the meetings, participate through comments, and are willing to host pilot events. Observing countries submit comments and may choose to attend meetings, but a lot of times do not. They tend to participate remotely. So we had 61 countries involved. Just to give you an idea, and yes, I am aware you can't read this very small print, but we have countries ranging from Iran, India, Egypt, Tunisia, to larger countries such as India, the UK, Brazil, Netherlands. So pretty much all of the EU, South Africa, India, Germany, China, Russia, all participated in the development of this standard. In addition, we had a lot of observing countries. And so here are the observing countries: Romania, Serbia, Sri Lanka, some of these countries who attend primarily on a remote basis. Although the Czech Republic did send people to 2 of the meetings. So this is a voluntary international standard. Means it is not currently required by legislation. However, a number of countries, including Korea and Russia, are looking to promulgate this through national law. So although at the moment it is listed as a voluntary standard, it will become mandatory in certain countries, and it is up to each country to make that decision. It has a lot of benefits and is designed for small, mid, and large companies. The size of the company is not intended to be a barrier to implementation of this standard, and it is intended for all sectors: industrial, commercial, transportation, utility, etc. The estimates, if this was implemented worldwide, is that it could influence up to 60% of the use of energy.
Deanne, what's the current discussion in the U.S. about legislation? Federal, state by state, no way in hell? What's going on?
There is support for this in the U.S. government, and there are voluntary programs sponsored by the U.S. government which use ISO 50001 as a base for those programs. And I will talk about those toward the end of the presentation. There are states who are talking about how they might use this in legislation, but that is a state-by-state decision. The most active discussions are currently in states such as California, as you might expect. But we expect that it will remain voluntary in nature at this time. That is primarily the way it's going, voluntary with inclusion for incentive-based programs like the ones I'll talk about at the end. So why would anyone do this? Well, for industrial applications or even commercial applications, energy can be a major component of fixed cost. And so cost becomes one reason why organizations do want to look at this, although cost is not a driver in this standard. Depleting resources is a very big driver, particularly for Europe. They have some national legislation and directives related to reduction in energy and reduction in greenhouse gases. Although you cannot control energy prices, you can control how you use the energy. And so understanding and managing those business decisions is a key issue. And improved performance is another big issue, particularly when it can lead to advancements in the product itself or service that you're trying to provide. One of the other big drivers is that this is similar to other management system standards that organizations have implemented, such as 9001 or 14001. 9001 has over 1 million organizations who have adopted it to date, and 14001 has close to 500,000. So organizations who've already done this and are looking to expand either for sustainability reasons or to address European concerns related to greenhouse gas or energy use find 50001 to be beneficial for their application. So it's basically designed to help people make better use of what they have now, to create transparency and a common language that they can communicate from, to promote best practices and behavior, which can provide a lot of benefits, to assist facilities in determining the best energy projects to choose. Sometimes they don't make the best choices, or they don't get the intended results and they're not sure why. Because this standard is data-driven, it helps them understand that. To provide a framework for promoting this through the supply chain, which was a request of a number of different supply chains, pharmaceutical and automotive being at the top of those lists. To facilitate and improve greenhouse gas emissions and connectivity with the greenhouse gas standards, and to allow integration with other organizational systems. This standard can be certified, and there are 3 different ways an organization can choose to be certified. The most market-recognized way is through third-party certification. This is done through certification bodies. They come in, they're independent, they audit the organization, and they issue a certificate. They come back on an annual basis at a minimum, and they recertify the organization every 3 years. It's a fairly well recognized system, and most organizations are fairly familiar with it. The second way is through a second party audit. This is where the customer or a key contract that you hold audits the organization. Federal government uses this a fair amount. DoD, for example, has an audit entity that goes out and audits other DoD facilities, and they do this for 14,001. They will also be doing this for 50,001. First party is used in the marketplace. It has the least recognition in the market, but it is a very valuable tool. That's where you, as the organization, audit yourself and say, I do meet these requirements. It's only as valid as your word, and it has a limited recognition in the marketplace. You do not have to get registered. There is no requirement to do so at this time in the United States. So what have early adopters, people who've already started using the standard, had to say, and where in the world is it being used? This one is from an electronics company in China. They've reduced their power by 10.51 million kilowatts compared to their 2010 usage. They intend to do this in their other facilities, and they intend to be certified. They currently have over 90% of their worldwide facilities certified to 14,001 and intend to require them to be certified to 50,001. So in electronics, you can see that that's something they're going to do. You see a similar trend with Schneider Electric, which is out of France. They already have their headquarters building ready for an audit, third-party audit. Schneider Electric also plans to use this in their facilities worldwide. They do have about 90% of their facilities registered to 14,001 and also intend to register them to not 50,001, but the Global Superior Energy Performance Program, which includes 50,001 in addition to a performance requirement. So they've raised the bar a little bit for their facilities. Power Station in India is using this as well, and they expect to see, based on the rupee, a $96.4 million benefit from implementing this. And that's primarily coming from energy efficiency projects that they've implemented at the power plant. AU Optics in Taiwan, of course Taiwan is a province of China, expects to see a 10% energy conservation, which is 55 million kilowatts of electricity. Australia and Austria, I think I put Austria up here. Austria, this is a municipality in Austria that's up here. Electrical energy, they expect to see a decrease of 25%. With the main savings being achieved through improvements in the pumping systems for their wastewater plant. Okay. And this will be about 16,000 euros in terms of dollar savings and 86,000 kilowatt hours. All of these were reported into ISO when ISO was asking for early adopter information, and this particular article is published and available online in their July 26th article, History Archive. The standard itself, 50,001, is based on continual improvement cycle. Plan, do, check, and act. This is a visual representation of that. Most people are used to seeing a cycle for plan, do, check, and act, which is represented down here by this little gray circle. And then they've put plan, do, check, and act around the circle. So how is this structured or organized? It's organized as you might expect. You have some basic requirements of who should be doing what, so some responsibilities and authorities. You have some basic planning, some things that are unique here to this standard compared to other standards is this part right here, which is all data-driven. Energy review, 443, 444, energy baseline, and 445, energy performance indicators. So it is a very data-heavy, data-driven standard. Implementation and operation, checking. Again, you'll find there's a lot of data embedded here. The other thing that you'll see that occurs in every single section of this document is energy performance and the requirement to continually improve energy performance. So it's a data and performance improvement based standard. And then finally, the review of what's happening and where to go next. The standard uses a concept field throughout the entire document. The first half of the concept is energy use. How are you using that energy? It's the manner or kind of energy. So, how are you using it? What are you using it for? That's the first part of it. And now that you know what it is you're using and how you're using it, the next concept is energy consumption. How much is that use using? How much consumption is there? How much energy is that lighting using? How much? It's separate from use, but those two concepts appear together. So we want to know how it's being used and how much it's using throughout the whole process. Otherwise, it's very difficult to figure out what it is you can do if you don't know what it is that's using the energy. And the key concept behind this standard is improving your energy performance. So you're going to improve energy use and energy consumption. The value of a management system approach is connectivity of concepts throughout the document. This is just one example. There are several hundred examples of this throughout the document. This is a very simple connectivity example, showing energy policy. So in this case, energy policy, seen on the far left, is connected to a number of things throughout the standard, including responsibilities, who's responsible for the policy, planning. The policy is kind of the way you steer the boat. So you should be heading the boat in that direction. You wouldn't want to have plans that contradict the direction you're heading in. Training, making sure everyone understands. Controls that lead to the achievement of that policy. And procurement and design that help you achieve it as well. And those are even further connected. For example, in planning, policy is reflected through the goals of improvement that you set through the objectives and targets process. The planning process itself is exactly that. It's a process. It has 7 steps to it. And it lets you methodically understand your energy use and consumption and what your opportunities are based on that information. So first it starts off with what you might expect. What am I legally required to do? In the U.S., there's not a lot of legal requirements related to energy efficiency, consumption, or use. But there's a few local requirements, and there may be some state requirements. A lot of these deal, for example, with access. Others of them deal with local codes. But there's not a lot of federal rules related to energy consumption, use, or efficiency. The Clean Air Act is the closest we come. But in other countries, this is a significant list. But first of all, start with what you legally must do. It's not a good day if you send your boss to jail. So start with what you've got to do. Then we're going to go through a process of understanding how and where we use energy, and we call that energy review. It looks at past energy data, current energy data, and future projections for that energy data. It also takes the current list of things that you have for use and consumption and focuses it into a set of smaller things you wish to focus on. And it calls those things that you want to focus on significant energy uses. For those, we're going to move forward and do a lot of things. First part of it we're going to do is identify and prioritize our opportunities. Where and how can we improve our energy use or our energy consumption? All of that is in the energy review, the second step. It's a very data-intensive step. Once we have our focused list of ways we can improve and we have our focused list of things we want to do something about, so our priorities and our significant energy uses, we need to establish a comparative point for each of these things. And those are called baselines. Believe it or not, that was one term we all actually could agree on internationally, baseline. So baseline is a comparative point. It is not a single baseline. It will be a baseline that is appropriate for what it is you wish to compare. So you need to have a performance indicator. How am I going to know if I am making an improvement in the performance? So that's step 4, the performance indicators, energy performance indicators. We wanted key performance indicators, KPIs, but that was already taken by the Greenhouse Standards Group, so we couldn't have KPIs. So ENPIs is the term we ended up with. Now that I know what energy I'm using, where I'm using it, how much I'm using it, how I've used it in the past, and what I think I'm going to do in the future, I understand my baseline or comparative point. I have a performance indicator set, and I know what I can improve. I need to set an objective and a target to get to that improvement. And that's what this is. And not only do I need an objective and target for that improvement, I need a plan of action to achieve the improvement. So that's what the 5th step is. But this is not a static process. It changes across time. And as you achieve those objectives and targets, or as your processes change, your equipment changes, your facilities change, your people change, then you need to update this information. So there's a review and update process built in as well. Okay? Does that make sense? It's a basic data process. So what am I going to get out of that? This is a typical example of baseline information. And the thing that's important to note here is that this does change the way a lot of people have looked at energy in the past, in that it introduces a concept called relevant variable. In this case, in addition to consumption data, we're looking at a relevant variable data of degree heating days. Okay? So it introduces the things that can influence or affect your energy consumption. These are called relevant variables. So one of the interesting responses to the standard so far has been the effect of this introduction. Without fail, pretty much every group who's tried to implement this has said that understanding these relevant variables has significantly influenced which projects they've chosen, why they've chosen those projects, and why they didn't get the results they thought they should have gotten in the past, is understanding how other things influence their energy use and consumption. ENPIs, this is a very simple dashboard that's up here, but ENPIs are how are you going to evaluate the performance? What is your measure of performance going to be? That's going to be different for every organization, and it's going to be different depending on whether you're looking at a facility level performance indicator, an equipment level performance indicator, or a process, or even a system, such as a steam system performance indicator. So you're going to need a dashboard of performance indicators and associated baselines that allow you to understand your energy performance based on the things you said were significant. Now that you have all of that, you're going to set objectives and targets. These are the things you want to improve. But when you set those, you need to think about other stuff. Are there any legal requirements coming down the pipe that I need to take into consideration? Are there any opportunities based on energy audits that I have done? Are there any financial constraints? Are there any technological issues I need to think about? New technology is a way to gain a stepwise improvement in your energy performance, but there needs to be a reason to do that, and you need to choose the right technology. Choosing the wrong technology isn't going to get you what you thought. So as you choose that and you set up the action plan, then you need to make sure that action plan is going to get the intended results. Unlike the other standards and management systems, this includes 2 new things to it. You have to have a means of determining what results you achieved, and you have to verify those results. So you're going to need a current performance level, you're going to need to verify the results you achieved, and this is going to tie into the measuring and monitoring section of this document. You're going to need the projected improvement. So you need 3 numbers for your action plan. You need to know where you are now, your starting point, where you plan to get to, your projected improvement, and you need a method to verify those actual results. So you need actual numbers when you complete it. So this is an example. This is from a Toyota factory. This particular factory happened to be in South Africa. They were looking at the cooling water pumps, and in particular the cooling water pumps in their welding plant. They decided to reduce it from 3 pumps to 2 while maintaining a flow of 487. I've pulled the units out for specific reasons and at the request of Toyota. They changed the pipe configuration after the supply to facilitate this reduction in the number of pumps. So the cost of this, and this is in South African rihas, was $38,000. Their savings in kilowatt hours per year was 332,500. The CO2 related to that was 308,955. Their cost savings estimated, again, rihas per year, is 167,700. And their ROI for their particular activity was 3 months. The internal rate of return for a project at Toyota is 2 years. Internal hurdle rate.
Dan, have you established, or has the community that's engaged in the standard established a good way of sharing best practices down to like technical implementations, calculations of metrics and things like that?
Have we established a way of sharing best practices? From country to country, they're doing this differently. In the U.S., we've established a group called the U.S. CEM, Center for Energy Efficiency Manufacturing. And they have a website and they are promoting best practices. In other countries, for example in South Africa, they have developed user groups which are doing the same. Internationally, there has not been a user group established internationally, but there are still a lot of additional tools in the areas of best practices and calculations that are just starting, so it is possible that some international best practice cross-sharing could still occur. So I won't rule that out, but right now it's being done nation to nation. So we've looked a little bit at that planning piece, so now we're going to take a look at the doing piece of the Plan, Do, Check, Act process. This includes training, documentation, operational controls, communication, design, and procurement. So it's a mixture of technical and soft, which is kind of an interesting group of things to mix. Training is a very soft side, and it has 3 components to it. Awareness training. Everyone needs to be aware that energy is important in the organization. This is your awareness piece. Technical training, as required. You don't want someone operating a pumping system who's never seen a pump. Okay? And competency. You need to define what people need to know to be effective at what they're doing, particularly as it relates to energy. Operational, this is more technical in nature. There needs to be operational controls and maintenance activities related to those things that you defined as important, which are significant energy uses. You also need controls and maintenance of anything that you declared to be an improvement activity or an objective and target, and the related action plans. So all of these things need operational controls and maintenance. That's going to mean criteria for what it is you expect, and measuring and monitoring that you're achieving that intended result. So, here's another example. This is not the Toyota plant. This is a group that wanted to minimize a user requirement. They were shutting off bypasses, determining actual flow and pressure requirements. There's a novel thought. What do we actually need? Oddly enough, that's not a question many people can answer. How much of this do you really need? They reselected the motors and pumps associated with the system and replaced a 28 kilowatt unit with a 6 kilowatt unit, achieving the same result for the users. This saved 75% or 176 megawatts. Just to give you an idea. Okay? This was from an operational and maintenance control activity. And this one came from a maintenance request because there was too much maintenance on the other unit because it wasn't being used as it was originally designed for. Design and procurement are a very important part of this standard. As you are probably aware, if you don't design it in, it can be very difficult to retrofit. Okay. The other side of this is procurement, particularly for maintenance activities and consideration of energy in those activities. For example, in a compressed air system, you can really kind of mess up the efficiency of a compressed air system by buying the really cheap O-rings. They might be really cheap, but they don't get you the intended result. A very easy example that many of you are probably familiar with. So those are the reasons why the design and procurement pieces are in here. It is aimed at any change in a facility, equipment, or process. For design and for procurement, anything that would significantly affect energy use or consumption. So the next part of the standard we'll take a look at is this checking piece. And in the checking piece, we have measuring and monitoring. So how do you know what you're getting? Evaluation of legal requirements, making sure you're meeting your legal requirements. Internal auditing, checking on the system itself. Non-conformance, corrective and preventive action, as well as correction. And records. So in measuring and monitoring, the things that you measure and monitor are things the standard uses a very broad term to represent, and that term is key characteristics. So the question is, well, what's a key characteristic? So they give us a list of what those things might be. And so here are things that are key characteristics. Anything that you said was important, the SEUs or significant energy uses, the pink bubble up here, is something that's going to have a key characteristic that you need to figure out how to measure or monitor. Other outputs from energy review, okay, those are that current consumption, for example, are going to be things you need to figure out how to measure and monitor. The actual versus expected energy consumption, particularly of those things you said you were going to improve. Okay, so for those things that you set an objective and target on. But also for those things that you said were significant. You want to make sure that if you are not improving them, that you are at least maintaining them. And that's going to be done by understanding what you expected the energy consumption to be. It's very hard to see how other things are influencing your energy consumption if you don't measure and monitor them. Remember that word, relevant variable? So that's one of the other things that you're going to be measuring or monitoring, are those relevant variables. So you can understand their influence. Objectives, targets, and action plans, you need to know if they're working. Are you achieving the intended result? So you're going to measure and monitor those. And then your performance indicators. Well, it's hard to be a performance indicator if you don't measure and monitor it. So that's the list of things that get measured and monitored. This is your minimum list. You're welcome to measure and monitor other things, but at a minimum, this list. So I know this is kind of an interesting little view of it. This is a very common view of metrics and what would come in. So people would have a lot of data coming in. This is the typical input column over here on the left. They do some sort of analysis of that through some sort of analytical technique. The one represented on the screen is a regression analysis. There are many other techniques that are useful. They understand their expected consumption, and then based on that, they look at other trends. And they look at how they can use that information to improve things. One of the biggest observations many organizations have had who've applied this initially has been on the base load. Many organizations had no idea what their base load was, what their load is when things aren't being serviced or made. And so this has been a big eye-opener for many organizations. Auditing, checking what's going on. If you check it yourself, and usually you will find some areas that are going really well, and sometimes you'll find some areas that need to be improved. That's the purpose of an internal audit. And they look at two things. Am I doing what I said I would do? And is my energy performance improving? And that's the two things that they're there to evaluate. They do this based on a schedule that you establish, and they plan it. It's not a surprise audit. It is a planned activity, planned and announced. And then once you have all of this, you want to make some new decisions and make sure that you are still in alignment with the organization's priorities. You do this through management review. So I'm going to stop there for a second. That's kind of an overview of 50001. And now what I'm going to do is move toward the programs that use 50001, both domestically as well as internationally. But I wanted to stop there and see if there were any questions on 50001. Okay. So we'll move to the programs that use 50001 as its base. In the United States, we have a program called Superior Energy Performance. Superior Energy Performance requires 50001 as the base, so that's your starting point. But since 50001 doesn't say how much you have to improve your energy performance, okay, it doesn't quantify that, SEP does. It sets those performance levels. And it is an auditable and accredited process. Now, 50001 would be audited in the United States by a particular certification body that is accredited in the United States by a group called ANAB, the American National Accreditation Board. This program, SEP, is jointly accredited between ANAB, which looks at management systems, 50001, and ANSI, which looks at verification of performance. So your greenhouse gas standards, for example, are done under an ANSI accreditation. This is the first program in the United States that holds a joint accreditation of both management system and performance. It is run by the U.S. Council for Energy Efficiency Manufacturing, or USCEM, and these are the organizations involved or behind the USCEM. So it's a pretty broad array of folks. Some of the commercial side that's not represented on this side because I did this slide for an industrial group. On the commercial building side, the participants are organizations such as Target, Walmart, Marriott, Hilton. We have a wide variety of other commercial entities as well, but just to give you an idea. So what would a typical performance be? These vary based on your industry or sector. So for an industrial sector program, that's what I have up here, they have 3 different levels of performance. So if you want to be silver, you would have a 5% performance improvement. If you want to be gold, you would have a 10% performance improvement. And if you wanted to be platinum, you would have a 15% performance improvement. Now, the question most people ask at that point is, over what time? Well, there's a base year, and then there is a 3-year performance period. So it's a total of 4 years of data. So your first year is your base year, and then you have a 3-year performance period to reach those numbers. You can apply and achieve this level in less than 3 years under specified conditions. And we did have one plant who's already achieved this at the gold level and did it in 2 years.
The energy performance improvement, there's a wide variety of metrics that can be used there.
There is a protocol that they apply that specifies the facility level improvement, how it will be calculated, and the statistical quantities that must be used. No, it's not open for debate. No, it is a statistically valid process. There are methods for both linear and nonlinear models. It is a facility level calculation, not a process or project level calculation. It is a facility level. And the protocol is fairly specific in how that will be calculated.
Does it have to do with just energy efficiency or net energy use?
Is it energy efficiency or net energy use? It is net energy use.
Your facility that's renewable, you can meet it?
Okay, no, we have a different protocol for that. The question was, can I put in a generator and get credit for that? If you put in something like CHP, and it is the first time you've ever used it, then yes, you can get credit for that. Okay, and a lot of times that, or something similar, you can get credit for that. Or you put in a new technology for purposes of improving your energy efficiency, yes, you can get credit. But after that first implementation, then we have a different way of calculating those types of things. And that also includes renewables, because you can actually, if you are producing enough internally and selling to the grid, then you would end up with a negative number, and that doesn't work. So it's a different protocol. Now, the numbers I just showed are for what we call, oh, I'm sorry, yes, sir.
Just a question. Without doing an initial audit, energy audit, how do you know ahead of time how much margin of improvement do they have?
They have to have a baseline of data, and it's compared to the baseline. That's how you know how much it has improved.
All these numbers, different numbers for different industries.
This is per facility. It's not per industry, it's per facility. So the data submitted is for an individual facility. The audit is at the facility, and it is the data has to be verified. So it's verified per facility.
By facility, do you mean by building or a group of buildings? Or
It can be a group of buildings. The scope is determined by the organization. So when we say facility, it is it can be a site that does include more than one building. It can also be a singular building, depending on that site. The numbers I gave above were what we call the energy performance pathway. So that is a pathway for someone who can demonstrate improvement in 3 years or less. But there are many organizations who've been doing energy efficiency for a while and who have cultivated all of the low-hanging fruit and wish to still participate. So for those organizations, we have something called the mature energy pathway. That's this down here on the bottom. So it looks at a larger array of data. This goes back 5, 7, or 10 years. Okay, so there's 3 options. I've used the 10-year numbers for demonstration purposes here. So at the 10-year mark, it's a 15% improvement using the protocol for evaluation of that number. And we have a scorecard. So for those of you who've seen the Green Building Council's scorecard for LEED, it's very similar in nature. This is a combination of management system practices and performance practices, and you have to get a certain percentage in the different categories, and you get certain points out of a total of 100 points, and depending upon how many points you get, then it tells you whether you're silver, gold, or platinum. So if you are a mature organization, there is still a pathway. Now, in the U.S., we have demonstrated this. This was demonstrated in the industrial sector with over 50 plants at the current time. Of those 50 plants, we have 5 who have completed the program and who are certified. We have 1 platinum, 2 gold, and 1 silver. We have another 13 plants who will be undergoing certification after January. And then the remainder are estimated between March and December of next year. The commercial building numbers are different than the ones I have up here. Commercial is a different sector, they have a different protocol and different numbers. That pilot is in process and is about halfway through, so probably another year before they're ready for certification. The U.S. program is based on a global program called GSEP, or Global Superior Energy Performance. It is run by a group called the Clean Energy Ministerial. It's a ministerial level program. Okay. GSEP was one of their 2010 initiatives, and they promote a lot of things related to clean energy and clean energy technology. Some of their current working groups include cement, certification, CHP, cool roofs, power, and steel. So they work in a broad array of areas. There were over 20 countries who participated in the development of GSEP, representing 25 energy ministers. There is a large array of countries involved who have signed on to GSEP, including a number of the European Union, South Africa, Russia, Mexico, Sweden, and of course the United States. They have started a pilot program for GSEP. It is an industrial pilot, and some of the countries participating include Argentina, Brazil, and the US. There are 8 countries in that pilot and 15 companies in the pilot. Questions over those programs? The global program called GSEP, and the US version of that, which is called SEP. Okay, y'all are excited tonight, I can tell. So where is this going next? What's going to happen next? Well, every technical committee produces a wide variety of work. In TC 242, the group that wrote 50,001, they are currently working on 6 new items. 4 of those have already been approved and have started, and 2 of those are expected to have approval actually at the end of this week. And all of them will begin work in October of this year at the meeting in Washington, D.C. So what are those areas? Well, one of the areas that is of high importance is energy performance indicators. How do you choose the right performance indicator? How do you measure it? How do you monitor it? This is a wonderful nest of questions that will be a lot of fun to unwrap on an international consensus basis. So this is one of the areas they chose to start with. Baselines. Although we all agreed on what the word was, I won't say we agree on what a baseline is. And so there is a work going on what a baseline is. And that is also going to be a wonderfully exciting and dynamic discussion. Those 2 items were the first 2 to be approved in the new work area for this committee. The next area is guidance. How do I implement 50,001 as a management system? This was the 3rd area to be approved for new work, and it has obvious need in that now I have the standard, what do I do with it, and how do I get from starting point to full implementation? The next area to be worked in or approved, and we expect approval of these, like I said, by the end of this week, is these 2 areas on auditing. There are 2 different areas on auditing. One is a technical audit of energy called energy auditing, and the other is the system part of auditing, or energy management system auditing. And so there are 2 different work areas there in the auditing arena. The last new area of work is on measurement and verification, and this is for organizations. So this is at the organizational level. So it's M&V of organizations. This is proposed to be a joint work area with energy savings calculations, which is a different committee. But because we wanted measurement and verification as a part of 50,001 and it applies to organizations, this will be a joint activity between those 2 committees. So this is the work that will start in October. Most of these are scheduled for a 3-year development plan. The other areas that are working in energy that you might find of interest is, of course, the energy dictionary or terminology, and that work is done by JPC2. It's called J because it's joint between ISO and IEC, the 2 of the international standards bodies. They have a committee draft that will be available actually next week and will be out for comment until January of next year. So if you have an interest in seeing how they have defined words, this would be something you're interested in, let me know. I'll be happy to provide that to you. And in March of 2012, the meeting will be in Argentina, and the experts will work again at resolving those comments. That dictionary addresses measurement and verification, energy efficiency, renewables, as well as energy supply, demand, and security. There's about 12 different topic areas that this document addresses. The second group may be of interest, in particular to a lot of you, is TC 257, Energy Savings Calculations. This group is fairly new. It has only been formed since January of this year. They have 3 areas that they are proposing work in. This is going to harmonize and create international standards on calculations of energy savings. So I'm sure you all know what a challenge that will be. The current 3 proposed areas, one is regional calculations. This is of great importance to many countries, particularly in the EU. How do we calculate or demonstrate energy savings at a regional level? Now, having said regional, let me define regional. Regional can be a neighborhood. Regional can be a city. Regional can be a country, a series of countries, or a physical geographical area that you define. Which is at least larger than a singular facility.
Such as a utility district or a utility
Yes, a
region.
utility district would fit under regional calculations. So regional does not mean what you typically think of as regional. I want to point that out. Okay? So this will be the first work, and this will be led by the Netherlands. The Netherlands is going to lead this particular effort. The next one is project calculations. Anybody ever heard of IPMVP? A couple of you? Okay. That was written by a group called EVO, or EVO. It is fairly well known in a number of countries and does address project-based calculations, but it is not an accepted international standard. This will be the international standard for project calculations. So how do you calculate projects? And just as a simple example in this arena, top down and bottom up are common words used when you do project verification. There is no international agreement on what those things mean. And believe me, what we think of in the US as top down and bottom up is not what the rest of the world thinks those words mean. And that's okay. If you ask any other countries, they don't necessarily agree either. So, yes, sir.
What would be the objective of regional calculations?
The objective of regional calculations is so that within particular areas of interest, they can say what the cumulative savings of a group is. So for example, if a utility did in a utility service district, they could say, in our district, we have saved this much through these efforts. Similarly,
From country to country or from...
you could also do a comparative from country to country, yes. So all of those were addressed in the scope of this new work item proposal. So it could be a series of documents. We do not anticipate...
So many variables involved that you won't be able to compare or come up with any kind of rational judgment.
I wouldn't necessarily disagree that it will be a very difficult piece of work, but it is probably going to move forward. And so, being involved in it and making sure that it is a calculation we can at least live with, since it will be an internationally approved calculation, and understanding what it actually means is one of the reasons why the U.S. did choose to become involved in that particular committee. And how do you compare across these things that don't even agree at a base level? We don't know. But we're curious to see what Netherlands is proposing. Yes?
Back to 50,001, with the work moving forward in the next few years on energy performance indicators and baselines, given that these things don't have consensus approval is what I'm hearing. How can folks implement ISO 50001? And how do they get over those hurdles, this roadblock issue that these don't have the same meaning yet?
Well, luckily at the moment, as you implement and you are certified to these standards, it's by country. So within the US, we have a fairly strong understanding of what a baseline is. And so that is the understanding that will be used. And it is actually the responsibility of the Mirror Committee in the United States to provide any interpretations necessary in the United States. So if a company or an organization wanted to say, what is this? They would send that to the U.S. Mirror Committee. It would actually come to me. I would go out to our experts in the U.S., get an answer, and then that would be how it would be done in the U.S. until this comes out.
And is there an existing document of already vetted answers to those questions?
No, there is not. We have one interpretation request currently, and I am in the process of working on that one, but it has nothing to do with ENPIs or baselines. It was from a registrar about a document, so it was an easy one. None of the difficult questions have been asked yet. The final area that is proposed for energy savings calculations is a wonderfully broad topic called energy savings calculations. This has been proposed by France, and it covers everything not previously addressed by the other two proposals. It is a very, very broad proposal, and we definitely anticipate it will be a series of documents as opposed to a singular document. These projects are not proposed to be on a 3-year time scale. These are proposed for a 5-year time scale. So the more traditional ISO timeframes. And we have a U.S. Mirror Committee for those. If you have interest in providing feedback on what is going to be developed in this, we would love to have you get involved. In fact, if you have an interest in any of those committees, it's one email address, and that would be mine, which is up here. It's just my first name, Deanne, then a period, then my last name, Desai, then the @ symbol, then GATech, which is for Georgia Tech, .edu, because we are a university. So you can email me, and I would be happy to assist you in getting involved with any of those. And there's my mobile phone number in case you have any questions. So, any other questions about this work or where it's going? We do know that there are at least 3 other proposals that we anticipate coming into 242. One is on energy efficiency design. That one will come in from Ireland. Ireland has a strong interest in that. They've already gotten it through their National Mirror Committee. They are now taking it through the European Standards Committee for approval, and we anticipate that that proposal will come in within the next 6 months. And so that work will start as well. Germany is interested in what is called phased implementation. We anticipate them to bring that to the Washington, D.C. meeting and either try and connect it to the existing approval for the guidance work, or if they're unsuccessful in that, in proposing a new document. And the third area is benchmarking. We know that the UK is interested in that particular area, so benchmarking is another area, and we have heard they're going to propose that either in DC or shortly thereafter. So those are the other areas we've heard about. Other questions?
Yeah.
Mm-hmm.
How many folks are going through this process at the moment? Any idea?
How many folks are going through this process at the moment? In the United States, through the Superior Energy Performance Pilot, we have 50 industrial sites and we have 12 commercial sites who are doing not only 50,001 but the additional performance requirements. We also know from input from the different organizations who are interested in certifying organizations to this standard, they currently have requests pending from another 75 companies, primarily being driven by the pharmaceutical, automotive, and electronics industries. Also Walmart.
So how many folks are planning to be certified?
No, asking certification bodies to come out to see them. How many others, like outside of the U.S., are interested? We don't really have a good feel for that. China gives us very large numbers, but how accurate those are, I don't know. The UK actually gave us a fairly low number, which we found a little surprising. But in the European Union, EN 16001 has not yet been withdrawn. It will be withdrawn in January, and so they've got two competing standards right now. But that's about the best we have at the moment. To compare it to how the other standards did when they were initially starting off, we actually have more uptake than 9001 did.
Follow up on that, how many agencies are certifying or being the third-party certifiers?
Third-party certifiers. How many organizations are going to be third-party verification groups? Well, there's going to be two kinds. The one for 50001, which is just an ANAB accredited organization, or a CB. We know of 75 who are interested. The second is the SEP. Those will be verification bodies. And that is a joint accreditation between ANSI and ANAB. And this is the first joint accreditation program in the United States. That program right now has 12 verification bodies. And the reason why it's a smaller number is they have to have an energy expert as a part of their team, someone who can do those energy savings calculations. And that narrows the field a bit. There's not as many energy verifiers around as people had hoped. It's a small crowd. M&V is hard. So it's a smaller crowd.
What would be the difference in doing a simple, take any industry, gold or platinum or whatever, and the company calls in experts to do the energy audit and minimize the energy use to the benefit of the audit, and compare that to the ISO 50000 that we're doing.
What's the difference?
And what is the advantage to the company?
What is the difference between an energy audit and an ISO 50001 audit? In an energy audit, most current energy audits at this time focus on where are you using energy, how is it being used, and what are your opportunities. And that's where it begins and ends. 50001 looks at your data for what are you using, how much are you using, but then it looks at performance. So not only do you have to have what are you going to improve, which is the results of the energy audits, but then you have to have results that you actually did make an improvement. And you have to have the data to back it up. So an energy audit would come at the beginning of a 50001 program. And after you had implemented those activities for improvement and had the results, then you would get 50001. So the benefit to the company is it produces a sustainable mechanism for them to choose the right projects to see a result and to have those results verified and agreed to externally that yes, they did improve their performance. So that's really where the benefit is to the organization. Other questions? No? Okay.
Well, can we thank Deanne for coming? I just have a couple of quick announcements and then we'll vacate. I didn't say at the beginning, I'm Kevin Vanden Wymelenberg. I even stumble over my own last name with the University of Idaho. Thanks for coming. This was the University of Idaho Integrated Design Lab's first event outside of our own little shop in Boise. So thanks to Kays and the Energy Efficiency Research Institute at Kays for helping to sponsor this and bring Deanne out. Also tonight we have Doug Peterson from the housing company, and Doug, in a minute I'll invite you up. He's also the co-chair of the membership committee for the USGBC Idaho, and they sponsored a little gathering here right after with some refreshments just next door. Hope you all stick around for a moment. And before I thank the other sponsors, there should be a sign-in sheet floating around, and I saw about 4 or 5 people come in late. It would really be helpful. You know, the sponsors like butts in seats, so if you even want to just jot your name down, that'd be great, but the full information would be helpful. And especially if you need AIA CEUs, make sure you give us your number. With that, thanks to Kays, thanks to Idaho Falls Power, Northwest Energy Efficiency Alliance, Better Bricks Program, and most of all, Deanne, for coming on out. Thanks. Doug, you want to come on up?
Thank you. I only moved to Idaho 4 years ago, but everywhere I go, I'm amazed at the weather. This totally freaked me out when I got here. I run the housing company. We're a nonprofit developer of affordable housing, and I built the first all-electric LEED certified platinum multifamily building in Idaho. We just won the 2011 Smart Growth Award for a project that we did in McCall. We work a lot with the green, and I'm also co-chair of the USGBC Idaho chapter. USGBC is really concerned about durability of all the projects that go on, whether they be residential, commercial, industrial, and also their energy usages. We are here to kind of introduce ourselves. You know, Idaho Falls is a place where we would like to have people that participate in our program. We're actually looking for somebody or some bodies to be board members. We have a meeting once a month on a Wednesday. People call in all the time, so it would be an easy thing if someone wanted to be a board member. Just call in. It's usually like a 12-to-1 type of a situation. Some of the committees we have is advocacy and public policy, programming and events. If anybody's ever been to the Smart Growth in Idaho, it's a weekend-long event that's pretty well attended down in Boise. We have the membership committee. We have emerging professionals. We're trying to get younger people involved in the things that we do and so forth. Marketing and communication, finance and fundraising. We have a green schools program that we're trying to get the officials in Idaho to really look at. And then there's a residential green building advocacy program also. Membership is pretty cheap for individuals. Companies can also join, and it kind of covers everybody within that organization. You can sign up online. It's not a terrible process to sign up online. I'm going to leave some of my cards here if anybody has trouble or wants to talk to me. I think we do have Italian food, so hopefully everyone can stop and have a little bit of Italian food. And if you go to www.usgbc.org/members/join, that's how you can become a member. So anybody wants to become a board member can talk to me, but think about joining, and I appreciate your time. Thanks.
Thanks, all. We'll have at it.